record here. Okay. All right, so what happened last time? We started doing probabilities, I believe. And so we want to do the number of times something happens over the total number of different possibilities. And so that was kind of the basis of what we do when we find probabilities. Whether it's what, theoretical, or whether it is relative frequency. So they had theoretical probability, they had relative frequency, and then they had that third one that I'm not even talking about. But whether it's those two, we calculate them the same. Oh yeah, 18 people. So I'm not logged in. 3 people are in class, are not in this thing. But if there are any questions over anything we did last time, 7A, now's the time to ask, I guess. But 7A, I talked about it. We did theoretical probability, I think, is one of the big takeaways. And then the other one is relative frequency. It's kind of the same concept. We're either making theoretical assumptions to make a theoretical sort of prediction, or we're looking back on information to make a statement about the probability that something happens. So one of them's kind of making assumptions and looking forward. One of them's kind of looking back at information. But they are both talking about probability, kind of the same thing. Okay. Ooh, I don't know if I put, what did I put for explanations of these? Okay, so decide whether each of the following statements makes sense. Is it true or does it not make sense? Is it clearly false? Explain your reasoning. So I know I didn't put an explanation on here, but in your homework, on a quiz, on a test, I would absolutely be expecting some sort of explanation. Oh man. Oh, after reading those tests, it's like, I don't know, man. The probability of getting heads and tails when you toss a coin is 0. But the probability of getting heads or tails is 1. So does that make sense? And what's my code for this? I need to join up. 072 089 If I just do that enunciation throughout the whole lesson. And we talked a little bit about this last time. Are we all answering? I think we all answered. 16 out of 15. All right, because I joined up and it messed up. I hope you said, what do we say? True, so I think there are 2 people that said false, but we talked about this last time. So if you get a head and a tail, that means you're getting a head and a tail at the same time when you flip a coin. If you do that, let me know how you're doing that, because that sounds like magic. And so, are we going to get a heads and a tails at the same time when we flip a coin? No, we're going to get one or the other. So the probability of getting heads and tails together is going to be 0. But if I think about getting heads or tails, this means I get a heads. This means I get a tails. Or I guess technically it means I could get both, but it's not going to happen. If the coin lands on its edge, get out of here. Okay. I guess if it lands on its edge. But that's not going to happen. But the probability of getting heads or tails. So this is saying you're either going to get a heads or you're going to get a tails or you're going to get both. We kind of don't think about that here. Is 1. So what this is telling me, this tells me that I'm either going to get a heads or I'm going to get a tails when I flip a coin. Where? Exit that annotation. forbidden side of the coin. Oh yeah, we're assuming it's gonna land on one of the flat sides, I guess. There's that little pig game that I had as a kid, and if the pigs landed in a certain way, if they landed both snout up or something, snout side down, it was like, this is never gonna happen. You cheated. You're getting all your points away or something like that. They took all your points away. I don't remember what that game was called. Toss the pig or something. Decide whether it makes sense. Same thing again. The probability of drawing an ace or a spade from a deck or card is the same as drawing an ace of spades. This, we're not even calculating the probability, but I mean, you don't have to, right? But you should kind of be able to tell me, is that saying the same thing? What does this do? Oh, it's fat. It's a regular line. Okay. What is this? Oh, that's a straight line. Ah. Arrow. Okay. What are y'all doing, three people? This is a like 50-50 question, man. This is why it takes so long to do this stuff. Like you're hitting a button. Read the problem, hit button. What are we saying, man? Come to class, be active. If you don't answer, then like the whole class waits on you. That's rude. This should be false. And a little bit of talking about why it's false. If we draw an ace or a spade, there are what, 4 aces here. There are 13 spades in a suit. So I know I didn't put the cards on here, maybe. But if you're talking about all the aces, all the spades, I think we got to add them together and then subtract the overlap. So I believe we're talking about like 16 cards all in all that are an ace or a spade. We will do a little bit more with the overlaps and stuff a little bit later. I talked about it in the notes, but we will have a few examples over it. If we talk about ace of spades, don't forget the joker, but no, it's 1 card. That's a horribly drawn one. Questions? 1 card is not the same as 16. If we draw from a possibility of 16 versus if we draw from a possibility of 1. And don't forget the joker. This is the weirdest line in that song, I think. Getting 5 heads when you toss 5 fair coins simultaneously. A lot of these are probabilities, and you should put them in reduced fractions. That's what I'm going to suggest. There might be a few times where I don't put them in reduced fractions. There might be a few times where it benefits us to maybe not reduce it. And where are we at? Load up, phone. I'm ready to answer my next question. Oh, is this independent or dependent? Shoot, forgot that question was the first thing we're answering. So if I'm flipping 5 coins, 5 fair coins, each one of those flips, I guess you could flip 1 coin 5 times. It's kind of the same thing. Or you get 5 coins and flip them all at once. Are those flips independent or dependent? So independent means they are all by themselves. They're not going to influence each other. Dependent means they are influencing each other. There's already one person just like logged in and fell asleep, huh? No, it's a different person. Okay. And so if I'm flipping coins, is it going to influence it? If I flip a coin now and then I flip a coin, I don't have a coin in my pocket at all. What the heck is that crap? If I flip a coin and then I flip another coin, Is this flipping this coin going to do anything about this flipping this coin over here? They are two separate coins. It doesn't matter. It's not going to influence it. So we will get to some examples where they are not independent. But when we flip coins, they are definitely independent. One's not going to influence the next flip. The flip of this coin is not going to influence the flip of that coin, right? That's what we're talking about. And so now we actually want the percentage, or not percentage, sorry. Probability is what the word I meant to say. The other P word. I want the probability. And I want the probability probably as a reduced fraction. This is probably already reduced if you just do it right, maybe. Oh, whew. And so I think we talked about this with ands and ors. So this is like an and statement.
I'm not sure if I entirely understand this question. Just finding, I think it's just the wording, getting 5 heads when you toss 5 fair coins.
Okay, so if I flip a coin, it's what? Half probability it's heads, half probability it's tails, right?
Yes.
And so when I do this and, is it more rare to flip 5 heads or is it more rare to flip 1 head?
5.
Well,
It's
I know
5.
like
So you should be getting a lower probability. So we want an
like,
operation and we have a bunch of halves, I think is what we're saying. And how do I make that a smaller probability?
So did it want it to say independent or dependent and then the fraction?
Yeah, now we want the fraction, the probability. How many times is 5 heads going to occur out of how many times total if you flip 5 coins? And if you really wanted to, you could probably list them all out. Heads, 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 tails. And then you got to like list all those different. Don't want to do that. We could do it. But you don't want to have to do that every time, right? You want to look something a little more mechanical that's going to get you there and not have to write things out that we don't have to write out. But we could write out, what do I want to say, like the solution set, the possible outcomes. That's what I'm looking for. We could write out every possible outcome if we wanted to. This kind of gets into the like counting principle too. I guess you could do trees as well. Trees are pretty good visual representation. Where are we at, 2 people? Try something out. Well, I thought this one would go a little bit quicker than maybe some of the other ones. It should be 1 out of 32. So let's talk a little bit about this. What are y'all doing? That's like a lot of people getting that wrong, man. 1 out of 10. No, 1 out of 2. Is it? No. No. I don't even know what that is as a percentage. I didn't even look. Reduced fractions are preferable. And so if we think about this, getting our first head is going to be 50%. Second head is going to be 50%. 0.5. I guess I could do 0.5 to the 5, right? 0.03125, I think, is what you get if you do it with decimals. I didn't do that. And so if we look at this, if we're getting what, 5 heads, we're multiplying 2 5 times on bottom, and we're multiplying 1 5 times on top. So this should happen 1 out of 32 times. And I said a little bit about it, and I don't want to do it, but I will start doing it. I could list every possibility here, right? And something like this. I don't want to do that. But if I did it, I should get 32 different options. This is coming back. We have 2 times 2 times 2 times 2 times 2 to the 5th options, right? And so there should be 32 different options. So there are a few different ways to think about that. And one of the options out of the 32 is nothing but heads. I think I changed this maybe from what it was in the note in the book. I think this was another child problem that I turned to heads, tails. But anyway, if we want to know all the different possible outcomes, there are 32 different possible outcomes. This is one of them. The other way, the way that we're learning in this section, is I take each of those possibilities, and when I have an and statement, things should be getting more rare, right? We put it as a fraction or a decimal. Oh. And so what I'm doing is it's not really centered very well, but each one of these is being multiplied. My multiplication is a little bit far down. It should be maybe a little further up, but I do a half times a half times a half. So anytime I want to do things in combination, and even just getting 2 heads, right? If I want to get 2 heads out of 2 rolls, it's going to happen 1 in 4 times. If I add another roll to that, getting 3 heads is going to happen, what, 1 out of 8? Getting 4 heads would be like 1 out of 16. Questions about this? And so when I say and, I'm being really demanding, right? I want this to happen, and this to happen, and this, and this. And so each time, it should get smaller. And if I'm multiplying by a fraction that's between 0 and 1, things get smaller, right? Hope you made that sort of analogy in your head already, right? If I'm multiplying by a fraction between 0 and 1, which probabilities are, I should get a smaller number overall. And so I think this is one of those, select one of them. Is this the independent-dependent problem? Is that what it is?
Yes, it is. It's the independent or
So
dependent.
if I randomly draw and immediately eat 3 M&Ms in a row from a bag that contains 10 red M&Ms and 30 M&Ms total. So I take it from the bag, and this is what we call, they say it a really fancy way, I eat the M&M. This is called without replacement. So I do not put the M&M back in the bag. I'm taking them out, I'm eating them, they're not going back in the bag. Ooh. These are a little bit weird. You have to be really careful about whether they put it back in the bag or not, right? It changes things. I gave y'all too much, saying too much. Select something, I'm gonna select it for you. Come on, man. And so this, like I was saying, when you don't put it back in the bag, it's gonna change things. If I draw 1 red M&M and I eat it, drawing another red M&M is gonna change the probability on that. And so I want to think a little bit about that because it's what we're gonna solve next. We're doing 3 red M&Ms. I will get you through 2, I think. So if I want to do 1 red M&M, how many red M&Ms do I have?
You have 10 in total, I believe.
10 out
Yeah,
of
10 red M&Ms in total.
out of
30 M&Ms.
Out of 30 total M&Ms. And so if I want to know the probability of drawing 1 red M&M, what's it going to be? 10 out of 30, 1/3? Okay, so that's my first M&M. I take out a red M&M, I eat it up. Now how many red M&Ms do I have in the bag?
9.
I have 9 red. And then how many total do I have?
29.
Where's it? Where's that? There's my scroller. 29 total. Okay, I did 2 of them. Now I think we just have to do the 3rd one and figure it out. But these are a little bit weird. there is a certain process to them, right? We got to think about what we're doing each time, because this one is going to affect this one, is going to probably affect this one. And again, you want to reduce it if you can. If you can give me a reduced fraction, that's preferable. 60, okay. Math frac. Okay. Okay. Just do the Jeopardy theme while we're waiting. That's like the most annoying thing, man. I swear, like that draws IQ points off of you. I think they've like purposely made that song to do that. All right. that I don't know if that made him go slower or quicker.
Looks like it actually worked a little bit.
All right. I got something like 720 out of 24,360 if it's not simplified. If you do simplify it, it gives you 6 out of 203. And so I talked a pretty good deal about how to get this thing set up. But we're thinking about red to total. And I start out with 10 out of 30. And so my first red is 10 out of 30, or 1 out of 3 probability selecting it. And if we did replace it, right, this problem would be so much simpler. I would have a third by a third by a third. If I didn't eat things, if I put it back in the bag, each one of them would be independent, right? It wouldn't be affecting the next one. I could just do a third times a third times a third. So I don't know if anybody did that, but that's wrong on this one. It is right for the other, for maybe another case, right? But don't do that to yourself. If they are dependent like this, each one's going to affect the next. So like I said, I have 9 red out of 29 total. I take one red one, I eat it. The next one's going to be what, 8 out of 28. So each time the number of red is going down, and each time the total number of M&Ms goes down. So both of those numbers have to decrease. We multiply 10 times 9 times 8 on top. Ooh, excuse me. And we multiply by 30 by 29 by 28 on bottom. We simplify. I don't even know what they divided by, but there you go. They're divisible by what, 90? I think they're both divisible by 90 or something. I didn't do it in my head. I let my calculator do it. 6 out of 203 should be the probability that we get. Are there questions about this? This is something you should know how to sort of set up if they're dependent. This sort of, what do I want to say, pattern, it's going to come up. So you got to kind of know what's going on a little bit. And probabilities is what we're still doing. Is this a dependent, independent one? So I think we're answering independent, dependent first. Selecting an all-male 5-person jury from a pool of 10 men and 10 women. Oh my, it is lagging.
Are we picking them all at once or one after the other?
I think I think you want to think about it as like kind of one after the other. You got to select 5 people. You're going to select a male, and then you're going to select a male, and then you're going to select another male. Where are we at? One more person. Okay. So these, if we select a male, we pick a male out, it's going to change the probability that we select another male. We have 10 people to pull from, so these should definitely be dependent. Ooh, let's see if we can do it. So I want to select how many? 5 people from a pool of 10 men and 10 women. I'm going to have to write this one out, if I'm being honest. So I start out with what? 10 men out of 20 people total, I believe. If I add up my men and my women, there should be 20 total people here. So I start out, I'll give you a hint, 10 out of 20, I believe.
I thought it was 5 out of 20.
You're selecting a 5-person jury, so you have to make 5 different selections. But when you're picking men, and so you want to know what's the probability you will pick your first man. And I believe it's 10 out of the 20.
So 10 out of 20. Got it.
And then we got to do the second, we got to do the third, the fourth, and the fifth. Major fall and a minor lift. Yeah, it seems right. That's one right. If I put the right answer in there, okay. And so I want to tell you, we talked about dependent things and what they look like in that pattern. Yeah, I would say maybe it's a little bit maybe implied that we're doing these sequentially. If you understand like how juries are formed, maybe there's a little bit of implied knowledge in here that we're doing things sequentially. You go person to person and you verify them, right? It's like, what are the odds? this first person is going to be male? What are the odds the next person is going to be male? And I want the first person man and the second person man and the third person man. Man, 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 man. All right, where are we at?
Looks like there's one last person.
And it's just like one slow person, and it's not always the same person. It's like, what are y'all doing? It's not like the entire class is waiting on you or anything. Okay. It's like I don't know, man. Sometimes social shame works. Usually it does work. Not always, I guess. No shame. That's not a compliment. Always. Sometimes it's good. Okay, so it should be when I get 21 out of something, 112.92. If I multiply the top and, well, I'll just go to the next slide because I'm pretty sure it's on there. So I want to think 5 men. And so I select my first man. I think I said that's 10 out of 20. The second man is, what, 9 out of 19? So if I select one man, there's only 9 men left to select from. And there's only 19 people left to select from. And so each time, my total number of men and my total number of people is going to go down by 1 every time I take one out. And so it should go from 1020 to what, 616? And this is another one of those things, maybe I want to mention it here. 10 out of 20 is a half. Do you want to reduce this? Don't do it. Don't reduce this. Keep it big, ugly, and nasty while you're doing like this pattern. Because if you tell me a half, how do you reduce 1 from a half on top and bottom? It's not going to be very easy. So these, I would suggest just keep them big, nasty, and ugly till the end, if you can, right? As long as you're doing this pattern. Maybe after you do the pattern, you could reduce it. But I think this is what I was saying. I get 3240 and 1860480, something like that on crazy on bottom. And at this point, hopefully you get a calculator or something. Try to reduce that as best as you can. If not,
This is a really dumb question, but I'm having trouble reducing it. I every time I reduce it, I get a number that's not the answer.
do you have a calculator? Are you doing it on your calculator?
Yes.
All right. So the last time I talked about it, I know on the TIs, it's probably going to be all reflected. I know I did it last time with the, let me see. Where are you at? You're not coming up yet. Come on, you're already up. I believe in you. Oh, shoot. There it is. Okay. It took a second. So you should be seeing my TI, but I talked a little bit about this. If you have a calculator, it should be doing like the legwork for you, hopefully. 1860480, I think is what my number is. So if I type that in, that gives me a fraction or a decimal, sorry. Most of your calculators have it. On the TI, it is right here under math. And if you just frac it, it will give you the reduced fraction. You can go back to decimal if you really wanted to. But if it has that frac button, there's a good chance your calculator will reduce your fractions for you.
Okay, thank you.
The other thing to check is it divisible by 2, right? 2 is usually the most common thing to divide top and bottom by. And then I guess you just work your way up the primes after that. I don't know. Is it divisible by 3, 5? And I want to go back to sharing my quizzes as well as I share. Any question? How do I get 5 guys? I think you just got to go up in order. It's not that big a deal. So sorry. What's the probability I will get 5 guys? You got money? They'll just take it. Just gotta tell them what you want to eat. Yeah, okay. Enough horrible jokes. 28. Now we're doing either or. So I think we're doing ands. Now we're doing the either ors. Determine whether the events described in each exercise are overlapping or non-overlapping. Then find the either or probability of the events. So we were getting a sum of either 2, 3, 4, or 5, and you roll 2 dice. They're talking about 6-sided dice. Last time we did 4-sided dice. Are these overlapping? Meaning, are they going to occur at the same time? Or are they non-overlapping or like disjoint sets is like what we might call them maybe. If they were sets, they would be disjoint. They're not going to occur at the same time. And so what I hope you said is if we look at getting a sum of a 2 and a 3, are we ever going to get a sum of both the 2 and a 3 at the same time? That's not how summing dice works. So these things are definitely non-overlapping. We're not going to get different sums at the same time when we sum dice. It is a distinct sum, right? It's not going to be both a sum of 2 and a sum of 5 at the same time. It's going to look something hopefully like this. And we did it with 4-sided dice. I believe went up to what, 2 to 8. I think I expanded it with 5 and 6 on there now. And so in the inside, these are our sums. And if we get a sum of 2, 3, 4, or 5, when we roll a 6-sided die. So you might notice this is 6 by 6. I believe there's 36 different squares in here. And we want to know 2, 3, 4, or 5. I think that's what it said. Yes. What is that? Okay. This, I think I did these, a lot of these I think I did with the larger fraction, just in case you messed up or something and you got the probability, but for some reason you didn't reduce it. So a little bit to talk about when I do non-overlapping sets. This is my 2s. This is my 3s. This is my set of 4s. This is my set of things that sum to 5. And if I draw circles around these things, guess what about these circles? I know maybe here they're buttoned up against each other, but they are separate circles. They're not overlapping events, right? They're not occurring at the same time. These are each separate events. And so if I draw circles around what they're talking about, they shouldn't overlap. I don't believe they should. Oh yeah, man. How many times are you going to get either a 2, 3, or a 5? How many times does that occur out of the total of 36? Is what I'm looking at. Oh, there's 14. I thought less people answered. I wouldn't. Okay. I'll give you like 30 seconds to finish up.
Just let me know if I need to start playing the Jeopardy music again.
No, I think we're about done with this one. And so if you counted up each one of those squares that had either a 2, 3, or a 5 in it, I think you got 10 of those squares if you counted them up right. And what we're doing is 10 out of 36. If I want to reduce 10 out of 36, Divide both by 2, I believe I get 5/18. All right, so now I got my deck of cards. Ooh, that's blurry, but it will work. So I want to say I grew up with the deck of cards in my hand practically. I feel like went to public school. Anytime we take a toss or tax or whatever the heck they want to call it nowadays, and you got finished early, all you did was play cards.
The star test.
Yeah, I guess that's what it's called now, huh?
Yeah.
But yeah, anytime you took your standardized test, like they would always be so bored just playing cards, watching TV, whatever. But here's what a deck of cards looks like. And so I personally like said that because I personally take for granted, like I feel like everyone just knows what a deck of cards looks like. And then you get to community college and you have people that like come from everywhere in the world and they've never seen a deck of cards before. So when you start teaching probabilities with the deck of cards, these things and these traits that are like kind of secondhand nature to you from playing cards aren't necessarily, secondhand nature to everyone else. So it is kind of an eye opener sometimes when you start teaching people that have different backgrounds, right? Either or probabilities determine whether the events described. Okay, now we're doing overlapping or non-overlapping. Drawing either a black ace or a red king on one draw from a regular deck of cards. So if I'm looking at these, what do they say? Did they say a black ace or black ace, red king? So if I want to look at my black aces, I believe that is these two over in here. Ace of clubs, ace of spades, my red kings, I believe are these two cards over in here. So now we're answering, are these disjoint or are they overlapping? Is there any way that is going to occur at the same time? Are you going to get a black ace and a red king at the same time? If you can, let me know how you're doing it. And if you don't get shot, that's probably a bonus because you're probably cheating if you get both of them at the same time. So those are different things. And maybe it doesn't make a lot of sense because we don't have the juxtaposed sort of example, right? There are 52 cards in a deck. There are 13 cards in each suit. There are 4 of a kind of any card. And we start with ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we work with the face cards. The 3 face cards, Jack, Queen, King. And so now we want to know the probability of either drawing a black ace or a red king. And we talked about them being disjoint. So when they're disjoint, I'll give you a little hint. It is easier to find them when they're disjoint than when they are overlapping. When they're overlapping, there's an extra little factor we have to do in here. But if we're looking at disjoint, how many times can it occur that I either get a black ace or a red king? I believe I'm doing 1, 2, 3, 4 different cards out of how many total cards again? 52. So 4. What?
Oh, I said 52. Yes.
Yeah, so 4 out of. Where y'all at, man? What are y'all doing? I just like told y'all what to type in, and like half y'all still sleeping on this. All right, there we go. And so when they're disjoint, we don't have to worry about overlaps. All we do is we add them up. There's 2 aces, there's 2 kings. There are 4 cards total out of 52. So I'm hoping the disjoint stuff tends to be maybe a little more straightforward than the overlap. Because I think we might have another example here that might get at that. Maybe, maybe not. So drawing either a 10 or a heart from a regular deck of cards. So we're either drawing a 10 or we're drawing a heart. Is that overlapping? Is that disjoint? What is that? Here's my 10s. My set of 10s. Where are we at? And I don't want to do it yet. The other thing is what? Hearts. So do my 10s and my hearts have an overlap? One person? Come on, a little slow. I hope you answered. Please be a big, big bar and everyone get it right. That's what I'm hoping. Ah! What are y'all doing? All right, so let's look at this. If this is my sets of 10s and my other set is what? Hearts. This is what we're getting at here. I'm glad. I'm not glad y'all got it wrong, but hopefully we learned something from this. Are those sets overlapped or are they disjoint?
They're overlapping.
Yeah, and what is the overlap called?
Dependent?
Mm.
Well, it's overlapping.
Yeah, it's overlapping. What is it like? What is the overlap? What is the overlap when I talk about the 10s and the hearts? It's maybe it's too stupid of a question.
What, the 10 of hearts?
The 10 of hearts is the overlap of the 10s and the hearts. That's it. That's the word I was looking for. They have an overlap. Their overlap is called 10 of hearts. So these are overlapping. Is that what I said? That is what the solution said, right? Overlap. Yes, okay. Woo! Now, this is where things get a little bit weird. There are a few ways to do it. If you want to look at it pictorially, that might help you. I'm going to go ahead and write this on here. I'm going to do it. There are 13 hearts. There are 4 10s. And so when they were disjoint, all we did was add those together. And if you do that, you might notice something a little weird. If we add 13 and 4, we're going to get 17. How many cards do I have circled here?
17.
I do not have 17 circled. Count them up.
16. My bad.
16. Why is that? Because when I add this set and this set, what did I just do?
You
Added this-
counted the 10 of hearts twice.
I added the
Well-
10 of hearts twice. So minus 1 that's in their overlap, right? So you have to subtract your overlap anytime there is an overlap. Because when you add 2 different sets, you're adding that overlap in twice. You have to take back out whatever you added twice. So minus 1 for the overlap. The overlap here is called 10 of hearts, if I wanted to be really specific, right? So I believe I already told y'all what it was. We got how many out of how many? I think he probably finished that up. What is someone talking to me in the chat?
Wait, how many cards are in a deck again?
There are 52 cards.
52.
You never played that game, 52 card pickup?
Mm,
My dad, he joked like the magician, like, is this your card thing? Like he would take a random card out of a deck, throw it up, slap the deck midair, and just be like, is this your card? All right, and if you said no, he would just glance down at the cards on the ground and just be like, well, it's somewhere down there.
Well, one time I tried to play cards, and when we finished the game, he's like, let's play 52 pickup. And he threw all the cards on the floor.
Yeah, that's how it
I
goes.
get to pick them up.
I've never played that game, but I know of it, and it makes me laugh every time.
It's like snipe hunting, right? It's not really a thing.
Yeah.
Yeah. But I always like forget how to play card games. So they're like, hey, you want to play Go Fish? I'm like, sure, go fish. And then I'm like, wait, how do I play that again?
How do I do this again? The only card game I know, like from memory, is King's Corners.
What?
That's the only card game I know, King's
Right.
Corners.
13,
I've never heard of that one.
4 out of 13 should not
I
be
like
the same as 1/4. I don't know where you're
I
getting that
remember
from.
that one
Um,
to some extent.
the quick probabilities, right? Of drawing like a heart, we could also think about that. There's 13 out of 52 of drawing a heart, or we could think of that as like what, 1 out of 4 of drawing a 10 would be what, 1 out of 13 in the suit. So there are certain symmetries you can kind of use to your advantage in cards. If that makes sense. There's 13 cards here. Drawing a 10 out of 13 different types of cards would be 1 out of 13. This would be 1 out of 4 if I was drawing a heart. Those are things you can look at. Those are not things that you want to look at here. Those are probably going to confuse you more, if I'm being honest. What you probably want to do is circle like your hearts, circle your 10s, see what they have overlapping. So we have to add all that they're here. We have to add all that are here and subtract the overlap. But it's really important to know if you have an overlap, you have to subtract it back out, right? You're adding it in twice. That's what this problem is really trying to get at. They're trying to get at overlapping sets. Okay, I think we got what, 16? Where are we at? 11 people. What y'all doing, man? Talked about this. What are y'all doing? It's a third of the class. Do y'all have questions? What are y'all doing?
I did it. I did the -1 and then the 13 plus the 4 inside, and I got 9. So that would be 9 out of 52, right?
It should be 16. If
Where
you
do
do
I
4 and 13, that gives you 17, and you do -1, it gives you 16. Should be 16 out of 52. I don't know what to do if the third of you aren't getting this and not asking questions, but
I'm sorry. My brain is like pencil stuck in my brain gears.
oh yeah, I mean, I don't mind answering questions and stuff like that. Like, that's not what I'm trying to.
Because
That's not what I'm trying to gripe at. I'm trying to gripe at like the good third of the people here that are just like not in class or something. I don't know what they're doing because I just talked about this. I went extensively over this. Like, you've got 13 here and 3 more. You got 16 total out of 52. Like, if you have a genuine misunderstanding of what I'm saying, that's fine, man. But like, if you're just here and like you didn't answer this already, and
I already answered, and then
yeah, I know, I could have probably guessed you would have answered, but like, there's people here who aren't, and it's just like, what are y'all doing? We're in class right now. We're trying to learn this concept that you're gonna have on your test. This is a concept of probability. I know we're talking about cards here, but guess what? Real life, you don't know what the heck's going to happen, and probability is the best sort of tool you have, right? At predicting the future, at predicting a lot of things. So I know we're just talking about maybe cards here, but we could be talking about your life in whether or not you survive or something like that, right? It could be lots of things that are really, really pertinent. If you want to be in charge of things, these are the things you have to know, right? For risk assessment, this is how we're going to determine risk. Excuse me. This is how we're going to determine risk assessment, right? Is by looking at probabilities. We're going to do insurance and expected values next time. And so we're at the second section in the chapter that has 4 different sections. So in case you didn't realize it, math tends to build on itself. So if you're not here, or if you're not asking questions now, you're going to be even more lost tomorrow, right? So these are things we need to understand. And if you're not interested in understanding it, then good luck passing the class. Then I guess I don't know what to do. Not even passing the class. Good luck in life is what I have to say. Like, if you don't understand probabilities, you don't understand quite a lot, you know. They're not going to trust you to make a lot of decisions. And I got to say, I kind of agree with them. All right, so now I think we're just going into general find that probability. I don't think they're going to ask us dependent, independent, but it is absolutely something you should know. It is something you should take into account, whether there's overlap or non-overlap, whether it's dependent or independent. Use the method of your choice to determine the following probabilities. We're drawing 4 spades in a row from a standard deck of cards when the drawn card is not returned to the deck each time. So drawing 4 spades. We do not return the card. Did I break this one down? If I didn't, yeah, I did. I remember because I messed it up at first. The card is not returned. What does that tell you? I was going to put it there. What does it tell you if the card's not returned?
It's not going back in the deck.
Yeah, and what does that tell us? What should pop in your brain? I think that's a dependent question, right? Independent, dependent?
Dependent, right?
Oh,
Yeah, dependent.
It's dependent, so that means, does it change each time?
Yes.
I think so. Okay.
Took me a minute. I had to remember, like, which one's the independent and which one's the dependent one.
Yeah, so this one, it should be, I don't know what to say. I don't want to say hard. It should be somewhat complicated. It shouldn't be the same number over and over again. So I hope y'all do like these sorts of things, right? What do I want? 1 spade. 2 spade. I'm not writing out the word because I'm just scribbling it. 3 spade, right? And so I want to think about what do I want each time? 4 spades. What is the probability of getting my first spade? Well, I have 13 spades in the deck out of a total of 52 cards. I'll set y'all up that much. And then I want to think about how do I get my second, how do I get my third, how do I get my fourth. I think the most fair card game, and it's not in your favor, right? It's never in the player's favor. If you want to make money or you want to do the smart thing, don't go play a casino game. That's my advice. You're gonna lose. Each turn you decide to play is a losing turn, and we'll talk about what that means when we get to expected value. You're expected to lose money each turn you play. You may not, but on the average, you will. So this is a bit how they find the odds with like poker hands, right? That's kind of what we're getting at. What are the odds you'd get a flush? Would be getting what, 5 spades? I think we're only doing 4, so it's not quite a flush. But you know, when you watch them play Texas Hold'em or whatever the heck, this is kind of how they're doing it. I mean, I don't know. It seems like a lot of our reality kind of, you know, is reflected on reward and punishment, right? Or what's our reward versus like what is the potential punishment for this thing? And in order to understand those sorts of concepts, you got to know probabilities, right? What are the odds I'm going to get this reward? What are the odds I'm going to get this punishment? And I think I'm like hinting at what's probably coming next with the expected value. So what am I doing? 11 out of 4165. And so I talked a little bit about this, but first spade, second spade, third spade, David spade. Oh no, fourth spade, sorry. 13 out of 52 is my first spade. 13 goes down by 1 to go to 12. And each time I'm going down 1 spade. Each time I'm going down 1 card on the bottom. I multiply the top, I multiply the bottom, I get that number on top, 17K. I get it around 6 million on bottom. I simplify that, it should give me the 11 out of the 4165. What is that at with the decimal? Sometimes it might help to put it into a decimal. This is 0.0026. So like a 0.2% or something, I think is what we're gonna get. So there's like a 0.2% chance or something you're going to get this. Very, very low. Questions about this? Okay. So a lot of this stuff is going to be mixed practice. You're going to have to determine, is one thing changing the probability of the next? Are they independent or dependent? These things would be dependent, because we are not replacing the card. If they talked about replacing the card, it would be different. It'd be a little bit easier probably. Drawing either a face card, Jack, Queen, King, or a club. And so I don't think we're going to have to, a club.
What's a club?
What's a club? Is this thing right here. These are my clubs. This first top row, this suit, these are clubs, these are spades, these are hearts, these are diamonds.
I understand. I need to learn a lot more about cards.
Club a seal to get a baby. Club a baby seal to get a better deal.
So there's like 4 clubs?
There are 13 clubs right here in this first
13
top line.
club, 12 faces minus the 3 because they're overlapping, right?
Oh, overlap. Oh, okay.
So 12.
And then I'll look at all these.
Yeah, I'm smart.
Ah,
3.
getting something down. Yeah. 15
I
club
must learn more
sandwiches.
about cards.
And if I look at my face cards, I believe there's 12 faces.
12 faces.
So there are 25 if I add those. But what do I got to do?
Minus the 3 club faces.
Yeah, so this is the overlapping sets, right? Clubbed faces. Okay. So that gets me part of the way there, and then I still got to find the probability, but that will give you. Oh man, I don't know what to do. I think you should get it from there, right? Uh-huh. Like I said, I know we're doing cards. And cards is just a game, but you know what? So is life. All right, so
The game of life.
it's basically an RPG, and I leveled up all the wrong stats.
I know how that is.
Okay, so
Get, like, debuff that
there are
forever.
two people that fell asleep or something. I don't know what you're doing. I told you what the numerator was going to be. It's going to be the 13 in the clubs, and we got the 12. And then we subtract 3. I shouldn't have deleted that. That was what, 13 clubs and 12 face cards.
Yes.
Cards. I can't type the right thing. Minus 3 that were club faces. That was the Jack of clubs, Queen of clubs, King of clubs. And so 25 minus 3, I believe that gives me 22 cards that I want out of what, 52 total? So if I do 22 out of 52, I believe I divide top and bottom by 2. Gives me 11 out of 26. Should give me the probability. What else are y'all telling me? Let me clear all this. What are my other responses? 11. What is that? 12 out of 22? 11 out of 26, right? 11:26, you're just looking in the back of the book. 11:26, y'all are looking in the back of the book. Don't tell me no different. I know y'all are. There's no reason you should put that other than you're just looking in the back of the book. How do I know that? Because that's what the back of the book put, and they're wrong. It's not 11:26. It's 11 out of 26. So, yeah, I know the answers are in the back of the book. If you want to, you can go look there. You can totally cheat class, right? You're going to cheat yourself. I don't care. Like, go ahead. Do it.
I'm gonna be honest, I completely forgot that the answer's on the back of the book. I completely forgot all
silly.
about
Like, I don't know why you would do that. Like, you're just refusing to learn stuff that, like, I'm not trying to be rude, but it's not. It's a lot. It's just like you're just doing more work to like not learn stuff at some point, you know? Is it silly?
Well, I just look to check my answers. I'm like, oh, I messed up somewhere.
Yeah, that's fine. But like if you're putting 1126, that doesn't even make sense for the question. Like you're not even reading the question then. You're just putting something from the back of the book to make me happy, which is silly. Because this class isn't about making me happy. This is about you learning more stuff. Like you're gonna see me an hour, right? Or whatever it is, an hour and a half each week, 3 hours each week. And then after you're done with this class, if you don't want to see my big ugly face anymore, you ain't gotta see my big ugly face anymore. You know, like that's the reality of it. But you're gonna have to go look at other people's big dumb ugly faces, and they might be just as full of it as I am. So you need to educate yourself, not for this class, but for yourself, right? So I'd like, if you're taking this class and you're doing things just to kind of appease me and not learn, then you're not, I don't know what to say, besides you're not doing it right. Purchasing 5 winning lottery tickets in a row with each ticket has a 1 in 8 chance of being a winner. So this is probably why I don't play the lottery. Or purchasing 5 in a row. Are these dependent or independent? I guess is maybe one of the questions I could ask. If I win on my first lottery ticket, is it going to determine whether I win on my second lottery ticket? Does it matter?
No.
No. They're each
It's a
independent.
random selection, right?
It's
You
each
don't know which one's winning.
yeah, it's each independent 1 in 8 chance.
Uh-huh. The wording
How
kind
many?
of confused me a little bit, but like I understood to some extent.
Jeez, that's a big number. Okay. And so I said it's a big number. The denominator is a really big number, I guess I should say, right? It should not be a big. Hopefully, you realize that like you're not gonna do this, right? Purchasing 5 winning lottery tickets in a row, probably not gonna happen. Did I do that right? Okay, yeah. You should be getting a really small number, maybe a really large denominator. Is another way to say it. All right, so what, 2 more people gonna answer probably? We're right there at the time, 4:20, and I think we're almost done now. There's not too many more problems, I don't think. It's just this mixture view. So the probability of my first one is what? 1/8? The probability of my second one is also what? 1/8.
1/8.
The probability of my third one is also
1/8.
1/8. And I'm doing this how many times? 5 times?
5 times 1/8 equals 5/8.
Not 5 times 1/8.
No.
You got to do 1/8 times 1/8 times 1/8. So on the top, it should be 1, right? On the bottom, it should be 8 to the 5th, not times. 8 times 8 times 8 times 8 times.
Oh, dang. Then I messed up big time. I already know I missed this question.
It should be
Yep,
8
I
to the 5th.
I messed up.
32,768 is the number, I think. And it should be 1 out of those, right? The top is 1. The bottom is 32,768. So what else y'all telling me? 32.76. Y'all do 5 times 8. Is that what y'all did? 32.768 is right. Y'all did 5 times it. Yeah. Exponencies. That would be true if it was 8 plus 8 plus 8, but we're multiplying, so it should be exponents. 4 rainy days in a row when the forecast calls for 40% chance of rain each day. If it rains today, is it going to affect whether it rains tomorrow? It rained today.
No.
It can't rain tomorrow. No, it's still going to be 40% chance tomorrow. It's raining 4 days in a row. Yes. And I gave this one in a decimal. Since they're doing 40%, it's just easier to give this one in a decimal. Oh, shoot. I don't know if I put my leading zero on there. It's probably going to count it wrong since I didn't.
Do it in a decimal.
It should be a decimal. And I didn't put my leading zero. My calculator doesn't put the leading zero. That's why my brain doesn't do it. But if you program, you have to put your leading zero. You should put the leading zero. And so we're doing 4 days of rain. And if each day is 0.4, what are y'all doing? I'm trying to stay here forever. 40% is 0.4.
I'll break out the Jeopardy again.
0.4. 0.4, right? We're doing it how many days? 4 days in a row? Here, I don't know. I'm just going to delete that. Okay. Questions about this one? So I think the first question, the important thing is, are they dependent or independent? I don't think we're asking overlaps here. That'd be a weird question. But I think dependent, independent might be a good question. So each one of these is independent. It's going to stay at 0.4% chance. Doesn't matter what day it is. So 0.4 times 0.4 times 0.4 times 0.4. Did that give you 0.0256, I believe? It's probably going to go wah, 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 wah. 0.0256. What did y'all tell me? I forgot to put my leading thing on there. 0.0256. 0.0256. It's probably not going to count it right because it's leading zero, but it's right. If you got 0.0256, that is it. If you got 1.6, you did something not moving your decimal, and you did not multiply it 4 times over. Or you did 4 times 0.4. That is not what we're doing here. Right? Y'all do realize that, I hope. 0.4 plus 0.4 plus 0.4 plus 0.4. This is going to get larger each time. This is going to give me 1.6. So if you're getting a 1.6 probability right away, you should be able to tell me what? This makes no sense, right? 1.6 probability makes no sense. We're over 100% probability. The largest probability can be is 1. So if you're getting 1.6 and it's a probability question, you should probably go resolve that if you're on a test, because that is not right. We're multiplying 0.4 over and over again. If we multiply things, this is going to be what do I say? Exponents, right? To the third, no. I did that wrong. To the fourth, sorry. If we do 0.4 to the fourth, we should get that number. 0.0256. Questions about this? Okay. If y'all do that again, it's gonna give me a heart attack. Definitely know the difference between multiplying and adding, and when you add multiple things, it's the same thing as multiplying. When you multiply multiple things, it's the same as exponencies. Gotta raise things with exponents. Randomly meaning either a man or a woman. Wait, I read that wrong. Randomly meaning either a woman or a Republican in a group composed of 30 men, 30 Democrat men, 20 Republican men, 50 Democrat women, and 60 Republican women. How many people are here total? 30 and 20 and 50 and 60. So I believe there's 160 people total. And I want what, woman or Republican? So how many people are either a woman or a Republican? Out of what, 160 total?
Wait, I don't think I heard. Did you want this in fraction or decimal form?
Reduced fraction.
Okay, thanks.
All right, so there are 160 people total. I get that from adding all these numbers up. Out of those, how many are either women or Republican? 30 Democratic men, are they women or Republican? No. So what am I looking at? Are these people women or Republican? They're Republican. Are these people women or Republican? They are women. Are these people women or Republican? Yes and yes, right? Doubly so. So I believe what I'm doing on top is the 60 and the 50 and the 20, which should give me what, 130 out of 160. Is that what we're getting? And if you do 130 out of 160 and you reduce that, I believe it should give you what, 13/16? Is that what we're getting, hopefully? What does it look like? If you tell me 0.8125, I guess that's correct too. That's just the decimal. 80 out of 160.
I forgot to reduce and I forgot to add one of the numbers.
You
I
forgot to
completely
add
missed
50 in there, I think is what you did if you did that, right? 110, yeah, you forgot to add what, the Republican men?
it. Yeah, I forgot to add the Republican men and I forgot to reduce it.
Yeah. Reducing it. Okay. So it looks like maybe some of us are getting pretty close, just didn't reduce it. Or I don't know how you got 140. That's kind of weird. But maybe you added the wrong one, Democratic men instead of Republican men. Did I not put the number of times? Oh, Jesus, really?
No, you did not. Okay, hold on. I have the book pulled up.
Okay, that would really help. What does it say? 5? Is it 5 times in this one?
Oh snap! That's not even. This is a completely different question.
Is it?
Random. Okay, in the book, 53 is randomly meeting a 3-child family with either all boys or all girls children.
Okay, so I changed it up 3 times. Here you go. It's a 3-child family and it's 3 times. It's the same thing.
Okay.
53. I need to add that back. And I think we did this in the notes even, right? Like how do you get 3 girls, girl, girl, girl? Or not doing girls. Heads,
Tails,
heads.
tails,
Tails, tails.
tails, tails.
So I believe this is gonna happen. Oh, wrong one. And think about how many different combinations of heads and tails you can have out there. How many different possible combinations are there of heads and tails if we do it 3 times?
6.
If you flip 2 coins, how many different? If you flip 1 coin, how many different possibilities is there?
2.
If you flip 2 coins, how many different possibilities are there?
4.
And if you flip 3 coins, how many different possibilities are there?
6.
Oh, no, it's not 2 times 3. It's 2 to the 3rd.
Ah.
Yeah, it should be 8.
Dang. It's like I think one thing and then it's like, no, you're wrong.
Yeah.
Dang. Okay.
So there should be 8 different possibilities. And either all heads or all tails happens how many times? Where are we at? Is anybody still working on this? Are people logging out? That's why I kind of want to know. Okay. Assume there's probably 10 people that are going to be active then. I don't know what to do. 11. I said there's 8 different possibilities. You get all heads or you get all tails. Those are 2 possibilities out of the 8. And if we're doing 2 out of 8, what are y'all doing? 3? No, all heads and all tails is happening. All heads is one possibility. All tails is another possibility. What are y'all doing? I don't know how you're getting 1/9 or whatever it is, or 1/8. Maybe you didn't look at both of them, the or.
I think that's what happened. I think we forgot the or part. We're just like, all right, it's heads and tails.
Yeah, I don't want to list them all out. We've listed them all out. But I circle the one that's all heads. I circle the one that's all tails. That's 2 things I have circled out of the 8. Okay, we get 3 questions that are all kind of the same, using the same setup. One-on-one free throws. A basketball player is fouled in a one-on-one situation, meaning she is awarded 2 free throws only if she makes the first free throw. So then we're trying to figure out what is the probability she will make the throw, basically. So her season average for free throws is 70%, 0.7. Using her season average as a relative frequency probability, find the probability that she will miss her first free throw. Oh, this is almost too easy. So she will make 70% of her free throws. What is the probability she will miss her first free throw? I'm looking at it from a decimal. I want a decimal. If this is 0.7, what is the probability she will miss it? So if she has a 70% chance of making it, she has a all right, so she has I believe it's a 30% chance. Is what happens when you don't do 70. And so if she's got a 70% chance of making it, she's got a 30% chance of missing it. What are you telling me? 30, that's it. What else would it be? 0.7 is the other part of that. 30% is good.
I think the computer's just being picky again. It's like, well,
Yeah,
it's
30% is good. 30% is good. I just want the decimal or whatever. It's good. If you're doing probabilities, you typically give them the decimal. You usually don't give them the percentage. Probability she will make her first free throw and miss her second. And I think one of the key words here might be this and word here. So she's going to make her first and miss her second. So if she makes her first free throw is what, 0.7? Let me clear that. Probability she misses her second is what, 0.3? So how do I find both of these occurring at the same time?
Subtract.
This is happening and then this is happening. And anytime you see this, you want this to happen and you want this to happen. What do I do with those probabilities? It's like I want a heads and I want a heads or something like that. Or I want a spade and I want a spade and I want a spade. What's the operation? Yeah, that's it. Okay. So if I want both of these things to happen in conjunction, right? The operation should be multiplication. So we do 0.7 by 0.3. I believe that should be giving me 0.21. And the last question, what are you telling me? 0.49. 0.49 would be making two of them, right? So if you have a 70% chance of making one of them, making two of them in a row, I might be giving too much. That might be the next question. Oh, shoot. So, probability
Thank you for the help.
probability she will make two of them in a row. Well, if she makes one, it is 0.7, and she makes another one's 0.7. So if you think about it, she's got a 70% chance of making a free throw. So she will probably most likely make one free throw, right? Is what this kind of tells me. Like there's a pretty good chance. But when I start talking about two free throws in a row, hopefully you realize the chance of making two free throws is less than making one free throw. And so we're almost there. we talked a little bit about this, but it's 0.7 and 0.7. This is giving me what, 0.49? So this is less likely to happen. It's like a 49% chance it's going to happen. The advantage is probably to bet against her making it, right? It's like a 51 to 49. I think that's what blackjack is too, right? 21. It is the most fair game in the casino, from my understanding. It's like has a really small dealer advantage, but it's still there. So it should be 0.49. Any questions over anything we did today? So knowing how to combine probabilities with ands and or statements is what this section is pretty much all about. And so when we go back to 7a, we did basic probabilities. So you got to know what a probability is back in 7a. You got to know 0 probability means that stinking thing ain't going to happen. You got to know 1 probability means it's guaranteed to happen. And anywhere in between there tells us the certainty, right? If we're like 0.5 or something, we're just making a shit guess, right? I don't know what to say. It's like, it's a 50-50 chance it's going to happen. The closer we get to 0, the less like it's going to happen. The closer we get to 1, the more likely something's going to happen. That was all section 7a, the first section. 7b of the section is all about ands and ors. So now we're combining 2 different things. What happens if this happens and this happens? So anytime you see that word and, I'm hoping you really think about multiplication. We're combining our options. So our options should be getting multiplied, the total number of options. So hopefully that should align with like what you're thinking, right? What am I talking about? So if we're doing a coin, it's a half for each time. So if I flip 1 coin, I got 2 options. If you look at your denominator, it should be matching how many total options you have, right? That's kind of what I'm saying. And each time we multiply by a half, our total options goes up by 2, right? So the bottom should be kind of telling you total number of outcomes. I can't circle things anymore, sorry. And it should be matching up with the total number of outcomes. So when we do ands, I want you to think about multiplying. The one thing you have to think about with ands when you multiply is it dependent or independent? So if it's dependent, we might have to do the -1 top and bottom, like we've been doing with the dependent episodes. And then if it's independent, it should be simple, like a coin roll is a half is a half. Here, these were independent. I don't know if I asked it, but her free throws were each independent of each other. So it did not change. It was either 0.7 if she made it or 0.3 if she did not. And then the other thing is ors. And so if you have ors, you can row your boat, but you can also solve problems with ors in them. We want to think about if the set is overlapping or not overlapping. If it's overlapping, we have to subtract the overlap from the number that we're getting. We probably added that overlap twice. There's a good chance you did that. And so you might have to subtract it. If it's not overlapping, then it should be easier. Then we're just adding the total number here. We're adding the total number here. We should just be adding them kind of straight. Questions about it? I know there's a lot to go over probably for the day, but there we are. If you got questions, I'm here. If not, I guess that's it.
Bye. Have a good day.
All right, take care. Stop share.